Today's video lesson is on acids, bases, and pH. Just a general introduction to acids and bases first. Let's compare some of the characteristics of acids and bases. Acids typically have a sour taste, like the citric acid in lemons. Many of our foods contain weak acids. Vinegar is a weak acid. Grapefruits, tomatoes are acidic, but acids are typically recognizable by their sour taste. Bases, on the other hand, taste very bitter. Bases would have a bad taste or a bitter taste. I remember B, bitter starts with a B, base starts with a B, bad starts with a B. Bases taste bitter, kind of like if you've ever gotten soap in your mouth. The next characteristic that I want us to focus on is what their formulas contain. Acids formulas will begin with hydrogen. We are familiar with some common acids like HCl, hydrochloric acid, H2SO4, sulfuric acid. We talked about nitric acid, HNO3. These are just a few. But you can recognize acids because their formulas will begin with a hydrogen. Bases formulas typically end in OH ion. You'll see hydroxide ion. So, for example, sodium hydroxide. Sodium hydroxide is a strong base. Magnesium hydroxide, aluminum hydroxide. These are bases, so bases typically end in OH. What you will notice is that the characteristics of acids versus bases are opposite from one another. Acids taste sour, bases taste bitter. Acids contain hydrogen. In the beginning of their formula, bases formulas will typically end in OH. Acids, if you get some acid on your skin, it'll feel kind of tingly or prickly to the touch. However, bases feel very slippery, just like soap. They taste like soap, not very tasty. They feel very slippery. Imagine if you've got Clorox on your hand or a soap on your hand and get it wet. It's going to feel very slippery. Bases will feel slippery to the touch. Both acids and bases will change the colors of dyes. Specifically, two dyes that we need to remember are litmus and phenolphthalein. I will show you a demonstration in class of these color changes, but for now in the notes, let's write down what happens. With an acid, litmus paper will turn color from blue to red. Acids will turn litmus red. I remember blue to red means you have an acid. Say it kind of country, it makes it rhyme, so it's easy to remember. Blue to red is an acid. Phenolphthalein is clear and an acid. Phenolphthalein is clear and an acid. If you were to test with litmus paper for a base, if a base was present, it would change from red to blue. I remember blue starts with a B, base starts with a B, bitter starts with a B, bad starts with a B. They taste bad, they taste bitter. But litmus paper turns red to blue, means you have a base. Phenolphthalein in a base will be a very, very pretty pink color. Pink in a base. Acids react with bases, okay, to produce a salt and water. Bases react with acids to produce a salt and water. So basically, they react with one another, and the products will be salt and water. For example, if I use sodium hydroxide as my base, and I react that with hydrochloric acid, let's do a double replacement reaction with this and see what forms. Remember, with double replacement reactions, the outer two ions come together, so sodium and chloride, NaCl, there's your salt, and H and OH comes together. Remember, we write water in our replacement reactions so that it's easier to balance, write it as HOH. There's your water. So acids react with bases to produce a salt plus water. Finally, the last characteristic is they are electrolytes, which means when they're dissolved in water, they will conduct electricity. This adds to our knowledge of the other electrolytes. Remember, we learned that ionic compounds also, when dissolved in water or in the molten state, conduct electricity. So are acids and bases. They will conduct electricity when dissolved in water. So next, let's look at the pH scale. Most of you are familiar with the pH scale. It runs from 0 to 14. Our strongest acids are going to have low pHs, so the strength of your acid increases this way as you go lower, and the strength of your bases increase as you go towards this extreme. They're exactly opposites. Our strongest bases are going to have pHs closer to 14. If you have a pH of 7, that's when you have a neutral solution. I want you also to remember that water, if it's pure water, will always be neutral. The pH of a neutral solution is 7.00. pH of 7 is neutral. Notice here that we have some, on the acid side, I've got some tomatoes. It's kind of hard to tell with this black and white, but this is tomatoes, some citrus fruits, some tea. They're acidic, so lots of our foods contain weak acids. And then some bases are washing powder. Antacids are bases. They're opposite of acids, so they're anti-acids. Milk of magnesia here, that is also a base. There are some formulas that you need to know to perform pH calculations. There are 4 formulas actually. So my last slide here has the 4 formulas on it. You might need to pause this video here to get all 4 copied down. But the formulas we need to know that we're going to be working on Monday in class are numbered here 1 to 4. Hydrogen ion concentration times the hydroxide ion concentration will always equal to 1 times 10 to the negative 14. This is a formula we need to memorize. So if you know either the H or the OH concentration, you can always find the other using this formula. I do want to point out that when you have square brackets around an ion or a formula, the square brackets represent molarity, which we just learned in this unit, which is moles over liter. So those square brackets always represent the concentration of the ion. 2 other formulas, pH is equal to negative log of H. POH is equal to the negative log of OH. This is the concentration of the hydrogen ion, pH, concentration of the hydroxide ion here, POH. Now this little p is a math function, and it literally means take the negative log. That's why you see negative log here. You're going to be using your log button on your calculator. Finally, pH plus POH, when you add them together, always equal 14, which is the pH scale. I want you to remember that when you're asked to determine if a substance is an acid or a base, you have to refer to your pH, not your POH. Always refer to the pH. Make sure you remember that. In a solution, if the hydrogen concentration equals hydroxide, they're equal. That's when you have a neutral solution. The pH is 7. If H plus is greater than OH, that means the acid is the greatest, so it's acidic. If the hydrogen ion concentration is less than hydroxide, that means hydroxide is the greatest. It will be a basic solution. So if it's acidic, the pH is less than 7. If it's basic, the pH is greater than 7. We will be using these formulas in our guided practice in class. This concludes this introduction to acids and bases.